Welcome back to Erbs class, man. 5 minutes of math. I'm glad you're back. Talking about three-dimensional figures in geometry, of course. So today, surface area, pyramids and cones edition. So remember, surface area is exactly what it says. The area of all of the surfaces. Now, that total surface area can be split between lateral area, which is the area of everything except for the base. Now, prisms got two bases, pyramids and cones, one. Let's get a pyramid up here and see what we're talking about. Yeah, exactly right. Like that pyramid, don't you? Yeah, buddy. So, of course, the pyramid is sitting on its base, which makes all of the faces going up the side of the pyramid lateral faces. Yeah. So it's only right that the surface area formula has got two parts. Looks like this. Yup, there it is. Yeah, notice it's got two parts, right? So we're going to talk about them two parts in a second, but let's talk about what these variables mean. Capital P. Anytime you see a capital letter in one of these 3D formulas, it means of the base, pertaining to the base, right? So capital P means the perimeter of the base. Whatever shape your base may be, it may be a square, triangle, a hexagon, whatever. The perimeter of that base is capital P. Now L, I double underline that for a reason. Slant height. Not the vertical height, no. Not the edge height, no. Slant height. Up the face of the pyramid. This one. Yeah, that one. So notice the little box at the bottom. You geometry students know what that means, right? Yeah, that's the right angle. That's 90 degrees, right? So that slant height comes down the face of the pyramid, makes a 90-degree angle with that base at the bottom on our face. Yeah, that's what goes in there. And then capital B, of course, the area of that base that it's sitting on. So whatever shape that base may be, right? That base may be a square, it may be a triangle, it could be, like we talked about a lot of different stuff. So whatever shape that base is, find the area of that shape. That's what goes in for capital B. Yeah, exactly right. So now, I ain't forget about you guys that don't really do formulas. If you don't really do formulas, think about breaking this pyramid down. If you broke a pyramid down, wouldn't you have the base that it was sitting on and a bunch of triangle faces that laid down from the base? Yeah, exactly right. So, wait a minute. Isn't that the same slant height from the face of the pyramid when it was standing up? Oh yeah. So guys, there's gonna be a bunch of numbers in here, man. Don't forget that slant height you might have to find through some Pythagorean theorem or some right triangle using the vertical height and maybe a side in there. But slant height's not always gonna be given to you. But if it is, this makes it that much easier. And if you have to break that shape apart into the base and triangles, you can find the area of triangles and multiply it by how many there are. Oh yeah, base, triangles, surface area. So remember now, your surface area problem might not include all of these faces. So this might be easier to do it this way. Ooh, what about when the base is a circle? Ha, circular pyramids, remember what we call those? Cones, yeah. And of course you can see a cone flip this way or flip that way. I figured I'd draw them both. So if a cone is just like a pyramid, couldn't we pretty much use the same formula? I don't know. Let's get that formula back up here. Okay, so here's my formula for the surface area of the pyramid. Remember we had a slant height. We didn't talk about where the slant height is on here, but we know where it is, right? Yeah, that's exactly where the slant height is. So kind of the same as a pyramid. Except on a cone, there's no flat face, right? So all of those are exactly the same length on a cone. Remember, that's the hypotenuse of this right triangle too. So if you have to do a little math to get that slant height, make sure this is the height you put in that formula. All right, so isn't the base of this a circle? What's the perimeter of a circle? Isn't it called the circumference? Isn't it 2 pi r? Can I substitute that? Yeah, in capital B, we're still talking about a circle, right? The area of a circle, capital B for a circle is, yeah. All right, well, let's clean up a little bit. This 1/2 times 2, well, they kind of, yeah. So what's that leave me with? Very, very nice. So now, just like in a pyramid, we have a lateral area, or the area of this curved part. So let's say I just wanted to paint just the outside of this cone. That would just be lateral area, just this part right there. And then that, of course, is the area of the base. So I would add them together to get the total surface area, but only use what you need. Oh my gosh, speaking of using what you need, I hope that this helped out with whatever you needed, man. I appreciate y'all coming to check me out, man. I'll see y'all next time. Bye.